you so much. Thank you for having me. What I wanted to share with you today is perhaps like a bit of a, AI horizon and what's to be awaited, and also embed that in the context of our current research. We're working as a team, a very transatlantic team, both from the US, from the Center for Collective Intelligence at MIT, and from Poland, actually. And we're working together on humanoid artificial intelligence, and essentially what we're trying to do is perhaps feed some emotions to the machines so that they can be responsive to that in the future. So, a lot has happened over the past year. Just one example of how things have been changing is obviously Sophia, the robot that was granted citizenship of Saudi Arabia last year. And you can say it's just a PR move, but on the other hand, what is clearly visible here is that this situation has posed lots of questions regarding robo-ethics, right? Because now we have to wonder, what does this really mean that the robot has citizenship of any country? Can it sign a contract? Can it work, right? What could it do? And I also know personally one person who actually owns a robot that is a humanoid robot. It's a sex robot. And it is pretty much, like Sophia in terms of competences that it has. It can speak, gesture, mimics, all that is present there. It even has some degree of machine learning. So could the owner of that robot then apply for citizenship, for his robot and then officially marry the robot? Right? It's definitely a question that could be asked. At least 10 robots could apply, just like Sophia did. And because they are, just like Sophia, they could definitely be granted citizenship of a given country. And yeah, I think this is a very new horizon that we have. Another thing is quite obviously, something that at Google people know very well. The situation that for us, the AI society, the AI community and data science community has been very, very important is that, we've seen one case, one example of AI trespassing human cognitive competences, right? So we have seen how AI can reach beyond our cognitive horizon and show us spaces that we would have not discovered without it, right? And that was the case of AlphaGo Zero, redesigning the game of Go, not really playing it better than the humans, but really redesigning the whole paradigm. And the third case, also familiar, right, I guess, and very known here, particularly in this building, is Google Duplex that we've seen, and that is pretty amazing, at least in the narrow sort of specialization that it currently has, that allows this chatbot to actually, use natural language thanks to deep learning methodologies, deep neural networks, and speak the language in such a way that it's not recognizable from humans, which basically suspends the Turing test, right? That's what happened. The Turing test is, I think, no longer a viable paradigm for thinking about human-AI interactions and relationships because Google Duplex, also Cortana, are there already, and they're showing, demonstrating that we're beyond that phase. So that's actually very interesting for us as a team. We're working, as I said before, in the field of human-machine interaction and machine-human interaction because we want it to be reciprocal, right? So we are not thinking in one direction only. And what we're trying to do essentially is perhaps collect as much as possible in terms of psychophysiological signal that can be released from the human body to understand how people feel when they interact with artificial intelligence. That's what's interesting for us. And we've been testing various technologies to do that, from portable electroencephalographers to, this is one of them, it also gives the user an option of a biofeedback that shows the user actually whether he or she is focused or stressed or something like that. There are many other devices. This is, again, a Polish example of a headband, of a mask that is a sleep management mask covered with many different sensors to really track what happens in the brain, but also like here on this level, ocular level, with the body, with the mind when the mind is resting. There are many other devices that were very interesting for us. We wanted to collect that signal to actually, first of all, understand what happens to the human, but second of all, perhaps also give the machine a possibility to actually understand the context of the conversation. So imagine if the user is actually stressed out, that influences the interaction. So perhaps AI, if we want it to be built and developed in this direction, could also be responsive to that. So other devices we were looking at were like wearable jewelry of different kinds. This is actually a chatbot. I don't know if you could recognize that easily, it's a chatbot and a pendant at the same time. There were some devices that we didn't like all that much, but they were sent to us because we organized this contest at MIT, asking really startups to send their stuff, right? Wearable technologies that could be used in the lab and also outside the lab. So we got this one, and this is actually, perhaps you know, with Pavlok, sending electric shocks whenever you don't fulfill a task. So punishing you actively, really. Rewards are not so good, it's just stickers, right? But when it comes to punishment, it's really severe. So we ended up not using this one because the ethical committee at MIT would never allow for that, and that's perhaps good. But there are several other devices we've discovered on our way, like neurostimulators and so on, and we ended up using this one, which is also a wearable technology that is pretty good at detecting alpha wave, at least, in your brain, and shows you whether the person is relaxed, actively learning, perhaps, acquiring knowledge, right, passively, or what happens to the brain, essentially. And why is it relevant? Because with devices like this one, you can actually do experiments outside the lab. I'm not interested in how the interaction looks like in the lab when I'm telling you to sit down and now talk to Alexa. I want to know how it feels talking to Alexa, Google Duplex, or any other chatbot, bot system that processes natural language when it really happens in your life, right? In your natural habitus, so to speak. So this device allows for that because when you compare it with a classical EEG, it's really a difference, right? Instead of 64 channels, you get only 7, and you could put it on very, spontaneously without any preparations, right? So we ended up using this one. Again, it's also like a device that informs the user what actually happens to the brain, right? And why are we using them? Here you can see the raw signal that you can get from it. And here, I'm not going to play it because we have little time, but I'm also showing how, it's actually, the video is in my house, but it's showing how my friend is steering a bionic hand with this signal here, right? So you can, see it, right? So we extracted the signal that is actually noise, essentially, jaw clenches and eye blinking, just to use it to steer other devices, right, in the IoT environment, in a smart home, for instance. All right, I guess we can move forward. So yeah, what I wanted to say is that really what we are observing right now are two things. First of all, evolution of context-aware systems. And here I mean chatbots, right? And second thing is growing importance of affective computing. And here, obviously, you have to be very careful with that data. Affective data, emotional data that you can collect from the smartphone, from a wearable technology like this one, this is something to be really ethically serious about, right? Because this is very sensitive kind of data. But on the other hand, it's data that can feed many different processes, right? And can be used with the right purpose, really, to achieve very important goals, right? So we've decided to use that data to find out more about human-machine interaction. And we carried out a study that was also featured by Forbes, New York Times, quoted several times, so I'm really happy about it. But the study was exactly about how people feel when they interact with chatbots. Not robots, but chatbots. We know that this conversation between humans and chatbots has long history, dating back to 1966, and Eliza, the first psychotherapist that I'm sure you know of, right? That was very, very simple and kind of stupid as a chatbot, but it was quite good at what it was doing, right? Even the responses like, oh, really, right, were good, right? Because whenever it could not kind of denote the sentence you were saying, it would just respond with, oh, really. That's what people do to each other, too, right, when they don't listen, for instance. So yeah, I mean, this was a very interesting case, and we were inspired by that and also other cases. My daughter's name, she's sitting here in the first row, Alice, is also inspired by this chatbot, Alice, Artificial Linguistic Internet Computer Entity, which was the first chatbot was using Zipf's law, right? So understanding that there is a certain amount of phrases in the language that are most important, and you have to focus on them, and you can just skip all the others. If you build them properly, decision trees for them, you'll be fine, and your chatbot will be good, right? Now we have all those robust systems, some of them using deep neural networks, and they're really interacting with humans more and more, I would say, adequately, right? So that's something very, very important. There are some interesting studies being released how, for instance, children interact with chatbots. There's one interesting study how kids talk to Alexa, and then they talk to each other like they talk to Alexa, right? And they were kind of giving commands to each other because they usually give commands to Alexa, like Alexa, order a pizza, or Alexa, right? I mean, buy me something on Amazon. So then they started talking to each other like that, mirroring actually the interaction with the chatbot. And then Amazon added please, right? So that at least this can be more sort of polite, right? But nonetheless, this shows you how important this is, also for the future generations, for the digital natives, right? They will have more exposure to these sorts of interactions in the future for sure, right? And there are also other interesting cases how a chatbot can go really wild, right? Like, for instance, this one, but they teach us something. They teach us something about the architecture of the systems, the values we instill in those systems. So that's kind of all very important for us. We ended up not building something outrageous. Our chatbot was pretty nice. It was a real assistant, I would say, right? So I have a bit of a problem with how people treat chatbots and the fact that they're those assistants, right? Perhaps that will change in the future. But like, we've conducted a study. We were looking for the so-called Uncanny Valley effect. I'm quite sure some of you have heard about it, right? So robots like Sophia or Bina 48, here not smiling back at me, notice. They are causing this effect of eeriness or a feeling of fear in people, right? Because they are too human-like. And we get to be afraid of that. That was described in the literature as the Uncanny Valley effect. And in the future, we can also assume that perhaps the Uncanny Valley effect will be different because of the exposure to technologies. But at least now, it's something that is really clearly there, right? For all the generations that are interacting with robots, if the robot is too human-like, you get to be a bit scared in most cases, right? So that was very interesting for us. We know that it exists, right? And I'm not going to go through all the geeky stuff, but if somebody's interested, I can share the paper we've written on that. We were looking for some referential studies that could help us to understand how people feel when they interact with human-like chatbots. And we built a chatbot like this one. This is Ola. She was on Kozminski University website for a year, speaking both Polish and English, thanks to deep translation systems. And she was working at the dean's office and responding to various questions. I wanted my students to feed her with knowledge about the university, and obviously they did not do that all that much. They decided to talk to her about different things, right? Other topics, like dating or like, curse words and stuff. But also they were performing a lot of Turing tests. So it was clear to me that they were making sure that they're just interacting with a machine. And that's very important. They were like always saying to her, do you know that you have no childhood, right? Or that you had no memories whatsoever. You don't know what happened yesterday and stuff like that. So it's clear, like for people, it's important to have these boundaries, at least now, right? They want to be sure about that, the fact that they're interacting with a machine and not a human. And so we created two versions of Ola. One was just text-based, and the other one was a humanoid robot. And we've added all those wearable technologies we had in store, electrodermal activity, facial myography, and so on. And we've added some questionnaires to ask people how they felt interacting with this chatbot, and was that okay? Would they like to work with it or not? And we've had two groups. One was talking to the text-based chatbot, and the other one was talking to the one with the avatar. And so what happened is that among those 32 participants, we've noticed certain interesting differences, right? So that was the methodology. Yeah, geeky talk again. And that's totally nerdy stuff. But like for all of you who are interested in psychophysiology, we've used BioPack. Okay, that's just, I'm going to leave it there. But so that's the technical details. But the hypothesis was really that, the reply of the human will be more intense when the human talks to the avatar chatbot with the face and the gaze and the voice and all those multi-channel experiences. And that's all the data we've collected. So as you can see, we've had quite a few channels of getting that data from the human body. And that's the procedure, right? So it took us a while. We had to hook the electrodes, and we had to make sure that the people are calm, actually, that they're not afraid, that they have some sensors on their faces, for instance, and so on, establish some sort of baseline. And then they had to ask certain questions and solve certain tasks with our chatbot. These are the tasks that they were solving. I know that I have to approach the end, and I'm getting there. I just wanted to show you the results. So the results, we'll just say perhaps one more thing. It was very hard to do this study. I'm not always saying it because I tend not to really brag about how hard it was, but it's really hard to do a study where you have no reference studies, and the chatbots are developing, and there's so much to work on here, and you discover a vacuum, and there's such a little amount of reference studies that you can use, and you don't know how to hook these electrodes and how to collect that signal. Did you know that, for instance, if something stimulates you, the signal from your body can actually rise only after 5 seconds, right? So putting the marker in the right place to actually understand what was the response of your body to that signal is a very, very very hard thing, and that's something that was really challenging for us in this work. So yeah, but that was the procedure, and we've collected the signal here. I'm talking about how hard it actually was, how to establish that marker in the proper moment, right? And this is exactly like how long it can take after the body releases the response. But then in the end, right, I'm going to skip that. I'm going to show you the results. I'm quite sure that this tells you a lot already. Yeah, but no, it's going to tell you a lot. Just notice that the red one is the simple text-based chatbot, and the other one is the one with sound and with the face and a gaze. So when you really process that data, you see correlations, right? So here you can see that the chatbot with avatar and sound was indeed more engaging for the users than the one that was text-based. But on the other hand, you can compare that across all signals, right? This is heart rate. Perhaps it's counterintuitive, but it is. And this is facial myography. So you can see the same correlation, right? All the time, the body signal is much stronger. But what does this signal really mean is the question, right? So what it means when you compare the signal, when you dig deeper in the signal, but also compare that with the questionnaires, is that people actually hated the chatbot that was humanoid, right? And it confirmed the uncanny valley. Because it turned out that the chatbot that speaks to them using voice and looks back at them because it has an eye tracker, right, and is trying to establish some sort of nonverbal communication, is something that makes them feel very stressed, right? And they don't want to work with it in the future, and they don't want to reveal any secrets to it, and so on. Whereas the text-based chatbot with the same engine is something that they perceive as, trustworthy, competent, and smart. Right? So only the channel kind of mattered here in how people evaluated our chatbot, not the knowledge engine that it had, right? So that was something we've managed to confirm in this study, right? So I'm not going to go through that. These are like just the conclusions, right? It seems like voice is a very interesting parameter, an important one, right? So you have to work very carefully with tonality. I'm also talking to people perhaps working with Duplex, if there is anybody here in the room working with this technology. Tonality matters a lot because even if you don't know it, subconsciously your body will react to the wrong tonality, right? And precisely will know where things are not well, right? Where it's not human-like and you expect it to be. So I think it's an important study. We're going to scale it up and use the methodology in other chatbots too in the future to kind of perhaps have an idea about how we want to develop humanoid AI dedicated to speaking to humans, interacting with them. That last gate of contact, right, with the user. It seems like people don't want to download apps anymore. They feel that chatbot, at least the younger generations, feel like chatbots is the proper gate of contact. But you have to really build that chatbot well so that things like that don't happen and you don't have that uncanny valley effect instead of something like a trustworthy sort of relationship, right? And this is what I wanted to say and share. And I'm clicking on the last slide and it popped up. Thank you. All right.